Hi, I'm Malachi, CEO of Elite Automation. Today I want to talk to you guys about robotic welding, some different use cases of robotic welding, and why robotic welding is so powerful. Three of the use cases that I have for you today are high production, high weld time, and job shops. Now for the job shops, we won't really get into today because that topic is quite a bit different from the other two, but the high production and the high weld time robotic welding is super powerful for multiple reasons. And the first one I'm gonna get into is quality. Why quality? It's because robotics can form the same motions over and over again, and they do it time in and time out for the next 20 years. And you don't have the same quality issues that you do with a human welder, where the welding can be inconsistent from shift to shift, or if that welder's not feeling well that day. Another side topic is that welder doesn't call into work, but that's another topic later on in this video. But also over time, you can take that robot and you can adapt its positions and its weld angles to get the most optimal weld. You can adjust your wire feed and speed, which you can do that in a normal setting as well. But with the robot's positioning, the robot position stays exactly the same every single time. And since that robot has that exact same positioning every single time, you can look at a weld and be a really good weld, right? And then you can optimize it from there. You can just tweak your weld angles. You can, like I said, you can adjust your feeds and speeds. Now, the thing that is a little bit different is because since you can control the position the exact same every single time, now that becomes a consistent variable of the welding process. So then you can go to your welder power supply and make some more fine-tuned adjustments on that side of things, because different welders weld differently at different speeds and at different angles, and that might affect what the welder needs to be set at. Now, a good weld can be performed with a various range of settings on your power supply, but to have the most optimal weld setup, you can only do that if you have very consistent controlled parameters, which is one of the #1 use cases for robotics. Accuracy and precision is always there, which brings me to the next point, which is having higher yields from your production processes. And this also goes into your feeds and speeds. Now you can put less weld fill material into every single part that you output. So when it comes to a high production setting or a high amount of weld time, that can be very critical. Whenever you're doing hundreds of thousands of parts or even tens of thousands of parts, every single weld can make a significant difference on how much the total cost of production is. And if you have long weld time, where maybe it's something that's like a 5-pass weld and you have to weld a 20-foot long weld, those type of welding processes are people welding on the same thing for day in and day out. And the optimization of how much weld you're using within a process like that can be very critical, and especially with the long weld time operations, because a lot of times guys who are doing those long weld time operations are just laying bead. I don't want to say they're not necessarily worried about how much material they're using. They're probably more focused on how do I get the best quality that I can out of this weld, and just making sure it's a good, strong, sturdy weld, which you can also accomplish with robotic welding. And I would almost argue that you could do it even better. But then the next thing that you have is going back to how the robot is so consistent. After you've gotten the robot doing a weld, right, it just accomplishes the weld. It isn't necessarily the highest quality weld, but it is a weld that is complete and it's precise every single time. Now you can go into an optimization phase where you can start to tweak the weld, you can start to tweak the weld parameters, the amount of material going into the weld, and through that optimize not only the quality, but the amount of material and electricity used in that production process. And to touch on job shops a little bit so I don't just completely ignore the job shops, the big difference between job shops and the high production welding is you're gonna have a lot more time on the processing side of things, right? So most of the job shops are gonna need some type of vision and some sensory tool on your robot that is going to give that robot the ability to identify and see the part, know where weld joints are gonna be at, and that processing time might take more time than just normal production welding, because that AI and that vision software that you're utilizing or sensors, whatever it may be, right, may not be the best for a high production run. And this kind of can go into a job shop that does high weld time, right? When it comes to something that's like high weld time and job shops, there's gonna be an analyzation phase where the robot has to analyze the part. Now, when I say for the high weld time ones, that's gonna be more of the job shop high weld time applications. Now, if you're doing something like trailer frames and they're exactly the same every single time, it may not have to go through this deep of an analyzation process, but it still may be a good idea for your robot to go through, scan one time, take a measurement of that product before it starts its weld, so that way it can make any adaptivity that it needs to make to adjust for any part ambiguity. Because one of the biggest problems with any type of welding, but especially robotic welding, is the parts that the child parts that are being welded are not always consistent. So when it comes to the long weld time type of applications, you might want to use things like that. Also, when it comes to the job shop atmosphere, you're definitely gonna have to have that, right? Those things are like super important. I think it's one of the big things that's missing from the job shop side of things. Now, you can pretty easily touch a point, weld this path, and basically be able to teach in parts like that, and then you can load in parts and then hit the go button, and then it can weld parts after you teach in your first few parts. But when it comes to like the AI type of tools, where it's really powerful, especially into the future, but even now there's tools on the market that we can utilize, but you can truly analyze your part, and with like 3D models be able to train in weld paths, and be able to, through simulation, be able to identify where the weld is, basically do all the weld scheduling and the robot programming through its 3D models and through tools like vision systems. Hopefully this quick little video was useful to you guys. If you have any more questions revolved around robotic welding, feel free to reach out anytime. You can also hit us up at rfq@eliteautomationusa.com, and we're happy to help you, and we're happy to drop more content like this. So feel free to ask any questions you may have, and we'll catch you on the next one.